So acquiring a carbon-13 NMR spectrum requires a very sensitive instrument. A little over 1% of all the carbon is carbon-13, so it's hard to detect. And only the chemical shifts are reported, so you don't get as much information from them. The values are going to range between 0 and 220. And we'll be looking at the number of signals, which is the number of non-interchangeable carbon atoms, that would carbons in different environments. So let's look at these compounds down here and see if we can determine how many carbons, how many unique non-interchangeable carbons we expect to have. So we have carbon here. I have green. There we go, green. And this carbon is identical to it. We've got two carbons here that are going to be identical to each other. And then these two carbons will be identical to each other. And finally, these two carbons. So we end up with 4 signals here. Here we've got this carbon will be identical to that carbon. This will be a unique carbon. These two will be the same, and we get one here. So here we've got, should have 5 signals. Oh, I left out carbons. We left out this one and that one. You have to remember we're counting carbons now, not hydrogens. So we get 5. For this one, this carbon is the same as this carbon. This carbon is the same as that carbon. This carbon is the same as that carbon, which is the same as this carbon and the same as that carbon. So you only get 3 different carbons here. So the only thing here to be tricky is that we've been counting hydrogens, and now you've got to look at the carbons, not the hydrogens. As far as shift, between 0 and 50, we'll get our sp3s. Between 50 and 100, we get sps and carbons that are attached to nitrogen or oxygen, so they're deshielded. Between 100 and 150, we will get sp2s, and we get carbonyls above 150. So let's look at some compounds and see what we can figure out. Okay, so first we've got to figure out how many different carbons we've got. We've got this carbon, which is actually going to be different from this carbon because of the stereochemistry here. The orange one is cis and the green one is trans, and so they aren't the same. This is a different carbon, and this is a different carbon, and we'll put the navy one here in the middle. Okay, and then there is symmetry, so we get these repeated. So that gives us 1, 2, 3, 4, 5 different signals. Now we need to figure out the regions. Okay, the green and the orange carbons are going to be in the 0 to 50 because they're sp3. The pink and the blue ones are sp2, so they're going to be between 100 and 150, and the blue one will also be between 100 and 150. I don't know if this is the best way to do this. The navy one is a carbonyl, and we'll expect it to be between 150 and 220. So here we have some more to look at. You might want to stop it and see if you can figure it out before we get to it. I'm going to number these this time. This one is one signal, and this will be the same signal. These are identical because there's no double bond. So that's one signal, two signals for that one. This is our third signal, and here's our fourth signal. So we'll have four signals. We will expect to see between 0 and 50 signals 1, 2, and 3. Those are all sp3 hybridized carbons. We'll expect to see signal number 4 between 150 and 220. That'll be signal 4 because it's a carbonyl. Let's look at the next one. This signal will be the same as this signal. That'll be a unique signal, but these will be the same, and these will be the same, and we'll put the navy one right down here. So we have 5 signals. All the signals will be between the 0 and 50 because they're all sp3 hybridized. So here we have a signal here, 1, and then we have 2. We have 3 and 3, 4 and 4, because those are going to be the same. Put the navy one here, and I'm almost officially out of colors. Here's, that navy should be 5. We're doing numbers and colors, trying to keep everything straight. And we're going to go back, and 7 will be. So we have 7 signals. Between 0 to 50, we'll have the sp3 hybridized ones, and that will be 6 and 7. Between 50 and 100, we're going to have our SP and our SPs, and there's one of those, and it's number 1 because it's a carbon attached to an oxygen that de-shields it, so that 1 down there, and between 100 and 150, that's where we get our sp2s, and we've got a lot of sp2s. We've got 2 and 3 and 4 and 5. All the ones that are on that ring. Okay, so let's look at F. These are the same. The carbons here and here are going to be the same. And then we'll have 2, 3. These 2 carbons will be the same. 4 and 4 we'll call them, and 5 and 5 will be the same. So we have 5 signals. Between 0 and 50, we'll expect to see our sp3s. That'll be carbons 1, 4, and 5. And between 100 and 150, we'll expect to see our sp2s, and that will be our 2 and our 3.